I've got a question for you. If I told you there was a new authentication technology that couldn't be phished, didn't require you to remember a password, and was being backed by Apple, Google, Microsoft, and basically the entire security industry, would you use it?
Absolutely. Actually, forget would. I already do. You're talking about passkeys.
Exactly. And we've been hearing the same sales pitch for the last couple of years. Passwords are the problem. Passkeys are the solution. No password to steal, no password to phish, no password to reuse across 12 websites because you got tired of inventing new ones.
Which, to be fair, sounds pretty good.
It does. And technically, there's a very good reason security people have been excited about them. But then researchers started asking a slightly different question.
Which was,
What if we don't attack the passkey?
okay,
What if we attack everything around the passkey? Windows, your browser, browser extensions, password managers, cloud synchronization, the authentication process itself.
so don't break the vault. Wait until somebody opens the vault door.
That's a pretty good way of putting it. And that's where something called pass-to-key comes in. Researchers demonstrated multiple techniques showing that an attacker may not have to crack FIDO2 cryptography at all. They can go around it.
Which immediately raises an uncomfortable question. Weren't passkeys supposed to stop exactly this kind of thing?
They were supposed to stop a specific class of attacks, especially credential phishing, and they're still very good at that. But phishing-resistant isn't the same thing as nothing around this system can ever be compromised. That's the distinction we're getting into today, what pass-to-key attacks are, how these attacks work, why Windows, browsers, and password managers suddenly matter so much, and most importantly, whether you should actually stop using passkeys.
I'm guessing the answer isn't as simple as yes or no.
Not even close. And that's what makes this interesting.
Before we scare everybody who just switched to passkeys, can we explain what they're actually doing? Because I think most people know the experience. Your phone pops up, Face ID, fingerprint, maybe a PIN. You're in. But what's happening underneath that?
At the simplest level, a passkey replaces the shared secret we call a password with cryptography. When you create one, you get a public and private key pair. The website gets the public key. Your device keeps the private key.
And the important word there is private.
Very important. When you log in, the website sends your device a challenge. Your device signs that challenge using the private key. The website verifies the response using your public key. If everything checks out, you're authenticated.
So unlike a password, I'm not typing some secret into a website and hoping it's actually the website I think it is.
Exactly. And your private key isn't supposed to be sent to the website either. That's one of the big security advantages. Imagine somebody creates a fake login page that looks exactly like your bank. With passwords, you could type your password into that page and hand the attacker your credentials. With a properly implemented passkey, the authentication is tied cryptographically to the legitimate site. There's no reusable password for you to accidentally hand over.
Which explains all those headlines saying passkeys were going to kill phishing.
Right. And there's real value there. The mistake is going from passkeys dramatically improve resistance to traditional phishing to passkeys can't be attacked. Those are two completely different statements.
Because eventually the passkey still has to interact with a something.
Exactly. Your operating system has to support it. Your browser has to support it. Maybe your password manager stores it. Maybe your cloud account synchronizes it. Maybe your organization connects it to Microsoft Entra ID. Maybe there's a recovery process. Maybe there's a hardware security module. There are a lot of moving parts.
So even if the lock itself is excellent, you've still got windows, doors, walls, and people carrying keys around the building.
Exactly. And that's really the theme of this episode. The cryptography can be strong, while the environment surrounding it creates opportunities for attackers.
Okay, now I'm ready to be concerned.
Let's start with probably the most attention-grabbing example. Researchers found that Windows was recording WebAuthn authentication information through its event logging service.
Hang on. Information as in what exactly?
A WebAuthn assertion. Think of it as the cryptographic proof generated during authentication. The server gives your authenticator a challenge. Your device signs it. The resulting assertion helps prove that authentication occurred using the correct credential.
And Windows was putting this into an event log?
That's the issue researchers identified. And that matters because Windows event logs aren't some unreachable black box. Processes on an already compromised machine may be able to access information stored there.
Which means we're not talking about someone sitting across the internet magically stealing a passkey. They already need access to the endpoint.
Very important distinction. This is not attacker knows your email address, therefore passkey defeated. The attacker first needs a foothold, malware, endpoint compromise, something running on the system. But once they're there, the question becomes, what authentication artifacts can they obtain?
And that's where passkey gets interesting.
Exactly. Researchers demonstrated how authentication material could be captured and used in a replay attack against Microsoft Entra ID.
Replay attack meaning I watch you authenticate. Grab whatever you sent and try sending it again.
That's the basic concept. The attacker doesn't necessarily need your private key. Instead, they're trying to reuse authentication material that your legitimate device already produced.
That's sneaky. Because when people hear passkey attack, they're probably imagining somebody somehow extracting this impossible-to-steal cryptographic key.
Right. But that's not necessarily the strategy. Why spend enormous effort trying to defeat the cryptography if the surrounding system gives you another route?
Was that fixed?
Microsoft patched the Windows vulnerability associated with CVE 2026-34348 in July 2026 after responsible disclosure. And that's an important part of this story. Researchers found the issue. It was disclosed. A patch was released. So we're not saying everybody using Windows Hello is currently defenseless.
But we are saying something bigger.
Exactly. We're saying security assumptions matter. People heard passkeys can't be phished and sometimes interpreted that as passkeys eliminate authentication attacks. They don't.
Okay, Windows is one piece. What about browsers?
This one might actually bother regular users more because browser extensions look so harmless. You've probably got some installed right now. Ad blockers, coupon extensions, password tools, PDF converters, productivity tools, maybe something you installed 3 years ago and completely forgot about.
I don't appreciate being personally attacked on this podcast.
Go check your extensions after the episode.
I'm afraid to.
Researchers demonstrated attacks where a malicious browser extension could interfere with the passkey registration process itself.
Registration meaning when I first create the passkey?
Exactly. That's an important moment. Because if an attacker can interfere while that credential is being created, they may be able to manipulate which key gets registered.
So we're back to the vault analogy. Don't steal my key afterward. Get involved when I'm having the key made.
Exactly. Imagine you go to create a passkey for an account. Everything on screen looks normal. You're on the legitimate website. Nothing screams phishing attack. But a malicious extension running inside the browser interferes with that registration process. The website can end up accepting a valid credential, except the attacker has control over the corresponding private key.
That is much worse than a fake login screen, because I'm actually on the right website.
Exactly. And that's why endpoint and browser security still matter in a passwordless world. Passkeys remove one very dangerous piece of the old model, the reusable password. They don't magically make a compromised browser trustworthy.
And I think that's something people miss. If malicious code is already running inside the system you're using to authenticate, you're starting from a pretty bad place.
Exactly. And the same rule applies beyond passkeys. If I control enough of your endpoint, I may not need to defeat your authentication protocol directly. I can attack what happens before authentication, or after authentication, or manipulate the interface you trust.
Which makes passwordless sound slightly less magical.
Still useful, just less magical.
All right, Windows, browser extensions. What's number 3?
Convenience.
Convenience is an attack vector now?
In cybersecurity, always has been.
Fair.
One of the great promises of passkeys is synchronization. You create a passkey on one device, and it becomes available on your other devices through something like Google Password Manager. From a usability perspective, that's fantastic. You don't want to enroll a separate credential manually on every phone, tablet, and computer you own.
Especially because the average person would simply stop using passkeys.
Exactly. But synchronization creates a difficult security problem. At some point, encrypted credential material has to become usable. If Chrome is going to authenticate you, some of the information necessary for that process eventually has to exist in memory.
And memory can be attacked.
Exactly. Researchers demonstrated techniques involving Chrome memory and the security domain secret used to protect synced passkeys. The concern is that a sufficiently capable malicious process on the endpoint may be able to obtain sensitive material that helps unlock multiple synced credentials.
So instead of attacking one passkey, you potentially attack the thing protecting a whole collection of them.
Right. And that's why you may hear the phrase golden pass to key. The idea is that one successful compromise could potentially expose access to multiple passkeys.
Okay, that feels much more like the password manager problem people already understand. You put everything behind one very strong vault. But now that vault becomes incredibly valuable.
That's a good comparison. Security engineering is constantly dealing with these trade-offs. If I isolate every credential onto separate hardware, I can reduce certain risks. But now usability becomes painful. People lose devices. They replace phones. They need recovery mechanisms. They expect credentials to follow them. So vendors add synchronization. And synchronization introduces complexity.
And complexity creates attack surface.
Exactly. That's the sentence I want people to remember. Complexity creates attack surface. Passkeys don't escape that rule.
I want to stop here because somebody watching this is already opening their settings and thinking, delete every passkey immediately. Should they?
No. And that would be the wrong takeaway from this episode.
Good. Because we just spent 20 minutes terrifying them.
Our job is apparently complete. But seriously, passkeys still solve major problems associated with passwords. Credential reuse, password databases, traditional credential phishing, weak passwords, users typing secrets into fraudulent websites. Those are enormous security problems.
So this isn't a story about passkeys being worse than passwords.
Exactly. It's a story about us expecting too much from one authentication technology. If your endpoint is compromised badly enough, a lot of security controls become vulnerable. Passkeys aren't uniquely cursed in that regard.
That's actually an important distinction, because there's a very clickable version of this story that says, passkeys hacked, passwordless security is dead.
Right. And that's not what the research means. The more accurate statement is, passkeys provide strong protection against specific attacks, but they're still dependent on the security of the device, browser, identity provider, synchronization mechanism, and implementation surrounding them.
Not quite as good on a billboard.
Terrible billboard. Much better cybersecurity advice.
Let's switch over to businesses, because I can already hear somebody in IT saying, fine, consumers can worry about browser extensions. We're deploying Windows Hello for Business. We have controls. What's the enterprise problem?
The enterprise problem is scale. One consumer with one compromised endpoint is bad. An enterprise rolling out passwordless authentication across 20,000 employees has a different problem. Now you've standardized an authentication architecture across a large environment.
Which is usually considered a good thing.
Usually, yes, consistency helps security, but it also means any weakness in that architecture suddenly becomes very interesting to attackers. Imagine you're targeting a financial organization using Windows Hello for Business tied into Microsoft Entra ID. You compromise an employee endpoint. You're running malware. Now you're no longer asking, can I steal the employee's password? Maybe there isn't one. Instead, you're asking, what authentication artifacts exist on this machine? Can I hijack a session? Can I capture something generated during authentication? Can I manipulate the browser? Can I register another credential?
So the attacker's playbook changes. It doesn't disappear.
Exactly. And I think that's one of the most important lessons here. Security teams can't take the old phishing playbook, delete the word password, write passkey, and declare the identity problem solved. Attackers adapt.
They always do.
They follow the value. If passwords become harder to steal, they'll target sessions, endpoints, recovery workflows, browser extensions, cloud synchronization, registration, identity infrastructure.
Which sounds suspiciously like zero trust.
We're getting there. Don't ruin the ending.
Sorry. Here's something I've heard a lot. Passkeys can effectively provide multiple authentication properties because you possess the device and usually unlock it using biometrics or a PIN. Doesn't that solve the MFA problem?
It strengthens authentication significantly. But again, we need to separate authentication strength from endpoint compromise. Suppose the legitimate user successfully authenticates. The passkey does exactly what it's designed to do. The biometric works. The key signs the challenge. Everything is valid, but malware is already sitting on that endpoint.
Then the attacker may not care about pretending to be me during the authentication step. They can target what happens around it.
Exactly. That's why identity security has increasingly moved beyond one moment where a user proves who they are. Modern security has to ask, what device is this? Is the device healthy? Where is the connection coming from? Is this normal behavior for this user? What application are they accessing? Should this session still be trusted 5 minutes later?
Because authentication isn't one event anymore. It's more like an ongoing decision.
Exactly. And that brings us right back to the zero trust concept. Never assume that one successful authentication means everything happening afterward is automatically trustworthy.
Would you tell an organization that's planning a passkey rollout right now to stop?
Not automatically. I'd tell them not to treat passwordless as a security strategy by itself. That's the mistake. Passkeys can absolutely be part of the strategy, but ask some uncomfortable questions. How secure are your endpoints? What's your EDR coverage? How tightly are browser extensions controlled? How quickly are Windows security updates deployed? How are passkeys recovered? Are credentials hardware-bound or synchronized? What happens when an employee loses a device? What protections exist around privileged accounts?
And I'm guessing the answer should not be, we deployed passkeys, therefore we're done.
Definitely not. For privileged administrators in particular, I'd want layers, strong endpoint controls, credential protections, conditional access, session monitoring, device compliance, tighter browser controls, potentially hardware-bound credentials depending on the environment.
Which sounds considerably less exciting than, passwords are dead.
Cybersecurity gets considerably less exciting the closer you get to actually securing something.
Let's make this practical. I'm at home. I've got an iPhone. I've got a Windows laptop. I've got Gmail, Microsoft, Amazon, maybe some financial accounts. I'm using passkeys. What should I actually change after hearing this?
First thing, don't panic and delete them. For most people, moving away from reused or weak passwords toward properly implemented passkeys can still be a security improvement.
Okay. Step 2,
Patch your devices, and I know that's incredibly boring advice.
the cybersecurity equivalent of eat your vegetables.
Exactly. Nobody makes a movie called Windows Update, The Reckoning. But vulnerabilities such as CVE 2026-34348 are exactly why patching matters. When security fixes are available, install them.
What about browser extensions?
Review them. Seriously. Open Chrome or Edge and ask yourself, do I actually know what every extension installed here does? Do I still need it? Where did it come from? When was it last updated? If you installed something 6 years ago because you needed to convert one PDF, maybe today is the day.
I feel attacked again.
Good. Third, protect the endpoint itself. Keep security software updated. Be careful about questionable downloads. Avoid cracked software and sketchy utilities, because remember, the attacks we've been talking about generally become much more dangerous once malicious code already has access to the device.
What about synced versus hardware-bound passkeys?
That's where convenience and security trade-offs come in. Synced passkeys are very convenient. Hardware-bound passkeys can reduce certain synchronization-related risks. For extremely sensitive access, especially privileged enterprise accounts, hardware-backed approaches may make sense. For ordinary users, the decision isn't necessarily cloud sync equals bad. It's understand that synchronization is another system that has to be secured.
What about backup authentication?
Absolutely have recovery options, but protect those too. Recovery codes, backup methods, account recovery email. Because attackers know that if the front door gets stronger, account recovery may become the easier door.
That's such an annoying rule of security.
Attackers are very inconsiderate that way.
I think there's something bigger happening here. Every few years, the industry announces something that's going to fix authentication. Password managers, MFA, authenticator apps, hardware keys, passkeys. And then somebody finds another attack.
Because we're solving an adversarial problem. That's fundamentally different from solving something like storage capacity. If we make hard drives bigger, the hard drive doesn't wake up tomorrow and develop a strategy for defeating us. Attackers do.
That's actually a great distinction.
Every improvement changes attacker economics. Make passwords harder to steal? Attackers move towards session theft. Require MFA? Attackers develop MFA fatigue attacks and adversary-in-the-middle phishing. Deploy passkeys? Researchers and attackers start examining registration, browsers, synchronization, endpoint memory C, and implementation details.
So security evolves because the attacker evolves.
Exactly, which is why security professionals get nervous whenever they hear the phrase, "This technology solves the problem."
Because it usually solves a problem.
That's the better way of saying it. Passkeys solve several major problems with passwords. That's valuable, but authentication security is bigger than passwords.
All right, so give me the final verdict. After everything we just talked about, are passkeys still the future?
I think they're an important part of it. But maybe we need to retire the fantasy that there's going to be one authentication technology that makes identity attacks disappear. Passkeys are significantly better than passwords in several important ways. They can dramatically reduce traditional credential phishing. They eliminate reusable passwords from the authentication process. They can give users a much better login experience. Those are real improvements.
But
There's always a but. A passkey still exists inside an ecosystem, an operating system, a browser, an identity platform, maybe a password manager, maybe a synchronization service, maybe a corporate endpoint. And attackers don't have to attack the strongest piece of that chain. They attack whichever piece gives them an opening.
which means the headline isn't really passkeys failed.
Exactly. The headline is, Authentication got stronger. Attackers changed where they attack, and that's a much more important story.
For regular users,
Keep using strong authentication. Use passkeys where they make sense. Patch your devices. Clean up those browser extensions. Protect your recovery methods. And don't assume that because you stop typing passwords, cybersecurity stopped being your problem.
and for organizations,
Treat passkeys as one part of identity security, not the whole thing. Endpoint protection, EDR, device trust, conditional access, least privilege, session monitoring, strong controls for privileged accounts. Defense in depth still matters, maybe more than ever.
and now you're allowed to say zero trust.
Thank you, because this is exactly why zero trust exists. You don't permanently trust a user because one authentication event succeeded. You continue evaluating the user, device, session, and access request. Because sometimes the credential isn't the thing that gets compromised. Sometimes it's everything around it.
And apparently that's our cheerful thought for the day.
We do cybersecurity. Cheerful wasn't really an option.
Fair enough.
If this episode helped you understand what passkey actually means, and why it doesn't mean you should throw your passkeys away, subscribe to Technically You. Because next time, we're taking the idea we just mentioned and going one level deeper. Zero trust. What it actually means, what vendors sometimes pretend it means, and why authentication alone isn't enough anymore.
That one might start an argument.
I'm counting on it.
Thanks for watching.
And we'll see you next time on Technically You.